Um,
So a square root, and a hint is that it has the word in it. The word of the inverse function of a square root is in the word square root.
power 2.
Yeah, exactly. So we're going to square both sides, or raise each side to the power of 2. Okay, so I'm going to have the x squared is equal to, now this square cancels out with the square root. So I'm going to have equals 2y minus 1. Thank you so much, Sulabet. All right, Delamar, are you there?
Yes.
All right, so now what do I need to do to get the y by itself?
You add 1.
Perfect, we can add 1 to both sides. So on the left-hand side, I have x squared plus 1. And then the negative 1 and the plus 1 cancel out. That was our goal. So equals 2y. And then I'm going to come over here to finish this out. All right, and then Peyton, I need you to do the very last step for me. How do I get that 2 away from the y? I'm going to rewrite it up here so that we have more space. X squared plus 1 equals 2y. So Peyton, how do I get rid of that 2?
You gotta, I was gonna say divide.
Yeah, perfect. Okay, so now I have x squared plus 1, thank you very much, Peyton, equals, or over 2 equals y. All right. And Eddie, are you there?
Yes.
All right, so what's the very last step? It says replace y with f inverse of x. What am I going to write right here?
F inverse of x equals x squared plus 1 divided by 2.
Perfect. Thank you so much. All right, so that was the hardest looking one on the page, and you guys crushed it. Good job. So we went through all 4 of those steps, and we found the inverse function of f of x. Okay, excellent work, guys. Again, I'm going to post all of these totally filled in. Actually, I think that they're already up. So if you are confused or if you need to catch up, you can open that up and you can just follow right along there. We're going to go ahead and flip to the back, and we're going to start working on the 2 properties of inverse functions. All right. So property 1, I really like this property. It's pretty straightforward. Is going to be if x comma y is a point on the graph of f of x. Okay, so x, y is on f of x. Then y comma x is a point on the graph of f inverse of x. Okay, so points on f of x are just flipped to get points on f inverse of x. Okay, so we're going to do these practice problems. These should be pretty quick to run through. So it says if the ordered pair 2, -5 is on the graph of f, what ordered pair must be on the graph of f inverse? So 2, -5 is the x comma y point on f of x. All right, so it's asking what point is off on f inverse. Remember that f inverse should be y comma x. So, Shayla, are you there?
Yeah.
Okay, so if 2, -5 was my point on F, what should this point be? The y, x point.
Rachel. I don't know.
Okay, so x was 2, y was -5. So I want to list y first and then x. So what am I going to write?
-5, 2.
There you go. Perfect. Thank you so much. All right, now we're going to fill in this table. Ayana, are you there?
She here, but your screen frozen.
Oh, okay. Well, have her message me. Tell Ayana, message me on Remind. Tell me what this first ordered pair is going to be. Okay.
Robert, she can't hear you.
She can't hear
you or none of that, like at all.
Okay, tell her to like leave the meeting and then come back in. Okay. I'll put her name to the side and we'll work it out later. Zion, are you here?
Yeah.
All right, so these are my f of x values, these points. It's asking for corresponding points on F inverse. So what am I going to write for this first pair?
Don't we have to like switch it or something?
Yeah, so what's my new x going to be?
3.
Yeah, and the y?
0.
Good. Can you fill out the whole table for me?
The x's are 4, 7, and 12.
There you go. Perfect. And the rest?
1, 2, 3.
Perfect. Excellent. What questions do you guys have on those two practice problems? Does that property make sense to you guys? Questions? Okay, we're going to move on to property 2. If you didn't finish property 1, don't worry. You can actually pull up the completed notes right now and you can copy them down. We're going to move on to property 2. So property 2 is maybe a little bit less intuitive. It says the graph.
Miss, can you please go back up? I didn't get to.
Peyton, please go back to Canvas and open up the filled out notes that are already there.
What?
Go back to Canvas, the page where we had our meeting today. It says activity 1, and there are filled out notes.
This is my question, Ms. Roberts. Then why are we doing this right now in class if it's already completed notes on Canvas?
Because I'm talking through them with you guys.
I don't understand.
You understand.
You going like real fast. All I'm asking you to do is just slow down a little bit. I mean, I can't write.
Peyton, the filled out notes are on there. You can go through. All right, but we have a very limited amount of time, and I want to try to get through them. All right, so property 2, we have the graph of F inverse of X is the graph of F of X reflected across the line y equals x. Okay, so I have a graph drawn in right here. All right, so if you want to sketch it out, feel free. And the dashed line is going to represent the function or the line y equals x. Okay, so that's what that one is. The f of x is the solid line. Okay, so f of x is this guy right here. I'll write in f of x up here. Okay, so f of x is the blue line, and we're reflecting across the line y equals x. Okay, and this works with any function. I'm just using a line because a line is pretty easy to follow. Okay, it's pretty easy to see how the reflection works. So it says the graph to the right shows f of x. On the same graph, draw f inverse of x. Okay, so for me, you could try to kind of look at this and say, okay, if I reflect across that line, maybe it would look something like this. Okay, you could try to estimate it, but I personally like to be able to see exactly what it would be. So what I'm going to do is I'm going to make a table of point values. Okay. So I can see that they have actually labeled points on this graph. Okay. And there are some that like I can clearly see exactly what that point is. And I'm going to write those down and I'm going to use property 1 to figure out what points of f inverse of x should be. Okay, so I'm going to make a table for f of x, which is the blue. And I can kind of see that negative 1, 7, 1, 2, 3, 4, 5, 6, 7 is a point. So negative 1, negative 7, excuse me, I think I said positive, is a point on f of x. So the point 4, 3 is a point on f of x. Right? And the point 0, negative 5. Oh, I forgot to label 4, 3. Sorry. There's 4, 3 and 0, 5. Those were just kind of the ones most obvious to me. You could pick totally different ones and that would be fine. Okay. But these are points that happen to be on my line f of x. All right, that blue line. So to get my inverse values, so I'm going to have x, and these are my inverse outputs. I'm going to flip all these points. So Sherlyn, are you there? Sherlyn? Okay. Amaya? Amaya, will you help me fill out this table? If I'm flipping all the points, what should my points be?
Negative 7, negative 1, 3, 4, and negative 5, 0, or 5, 0, sorry.
Actually, you were right. It should have been negative 5. I was wrong. Thank you.
Oh.
Okay, so we have points that are going to be on our new f inverse function. So I'm going to go ahead and plot those. So I'm going to go left 1, 2, 3, 4, 5, 6, 7, and down 1. I should have a point right here. Then I should have a point at 1, 2, 3, 1, 2, 3, 4 right here. And you can kind of see how it's reflected across right there. That one's pretty easy to see. And then I should also have a point at negative 5. So 1, 2, 3, 4, 5, 0. So right here. Any point that actually intersects the point y equals x, they'll share that point, right? And now I just take some sort of straight edge using one of your popsicle sticks. And I'm just going to draw my line through that point, those points, okay? If you have a non-linear function, you won't use a straight edge, obviously, but you can just kind of estimate between point values that you have, all right? So that one is my f inverse of x function, okay? And now it's pretty easy to see how I'm just pretending like this yellow highlighted line is a mirror, and I'm reflecting the point or the lines straight across. Each individual point on the original function is reflected directly across the highlighted y equals x line. All right, so what questions do you guys have about property 2?